Here's our first proof using series. So suppose that you have a series that converges and the terms are positive. So this part's going to come up in a few moments. You have to have positive terms and you know that this converges, then the square of those terms, that series will converge as well. Well, think about it. If this converges, if the series converges, that means that as you march along 1, 2, etc., the terms themselves have to be getting smaller and smaller and smaller. In fact, that was covered by the nth term test, which says if this converges, so if the series AN converges, then the terms have to get smaller and smaller and smaller until they're practically zero. Because if you're going to add things up, positive things, if you're going to add up positive things and it's going to be a finite answer, then what you're adding up has to be extremely, extremely small. Okay, so if eventually these things are going to become so close to zero that the limit is zero, then there has to be a point when they're less than 1. So as they march down here to here to here, there must be some point when they drop below 1. Okay? So we'll just call it M. So for this one, the way that I drew this picture, the M would be right about here. Here's M. You go past that number, and then they're going to be below 1. So that the individual terms are going to be below 1 from then on. The other important thing about series is that what happens for the first M terms, what happens for the first, say, 12 terms, 15 terms, that doesn't matter, because that can only add up to so much. You know, even if it was 3 plus 2 plus 1 plus a half, well, when you add up those 12 or 15 terms, that's going to be less than 10, I would say. So what happens for the first M terms doesn't really matter. What really matters is from that point to forever. Forever. Off to the right. Okay, so now I've got this inequality. So AN is less than 1 from that point on. Now what you can do is multiply both sides by AN. Now, here's the important part about this being positive, because remember, when you multiply an inequality by a negative, you have to switch the direction of the inequality. Well, I'm multiplying by a positive, so I don't have to switch that. So on the left side, I've got AN times AN is less than AN. Or this side is going to be AN squared is less than AN. And then look, that's what we needed, AN squared. So therefore, the series, when you add up AN squares, that will be less than when you add up the ANs. And since this one converges, if this is smaller, that means that it's going to converge also. So the series AN being squared converges also.